So today we have a car that enters the tunnel at 24 meters per second and accelerates steadily at 2 meters per second squared. And the question wants us to find the final velocity at which the car leaves the tunnel 8 seconds later. So first, let's identify some key information from the question, which is here. We have the initial velocity, 24 meters per second, the acceleration, 2 meters per second squared, difference in time, 8 seconds, and we need to find the final velocity. So first, looking at all the information that we already have, we should come up with a formula that uses all the information that we have. So we have difference in time, 2 velocities, and the acceleration. That looks awfully like the acceleration formula, which is acceleration equals difference in velocity over difference in time. So we know in this question we are trying to find the final velocity here. So what we're going to do now is try to isolate that value to the other side of the equation. So first we can move time over. So acceleration multiplied by the difference of time. This cancels out. It becomes difference in velocity. And then we can get rid of the initial velocity here by adding it to the other side. There we go. And now we can plug in the unknown values with the given values here. And then we can find the final velocity. And this will become, and I'll color code this. We have acceleration at 2 meters per second squared. We always want to plug in the values by using brackets to prevent any errors. Then we have difference in time, which is 8 seconds, plus the initial velocity, 24 meters per second. And that equals 16 meters per second plus 24 meters per second, which is 40 meters per second. And that is our final velocity right here. So we can write our therefore statement, which is the car leaves the tunnel at a velocity of 40 meters per second. Zoo. Oh, I realized you can't see that. Okay, there we go.